In this video, we're going to learn how to determine the molar mass of elements, molecular compounds, and ionic compounds from their chemical formulas. But first, we will just remind ourselves that the molar mass actually refers to the mass of 1 mole of a substance, and its units are expressed in grams per mole. In our chemistry studies, we're going to need to determine the molar mass across a number of different scenarios. For example, we need to determine molar mass for atoms and elements, for molecules and molecular compounds, as well as for ions and ionic compounds. So let's start with elements. Let's consider the differences and similarities between the atomic mass of an atom or an element versus its molar mass. Both will have the same magnitude but different units. The units for atomic mass are atomic mass units, whereas the units for molar mass are grams per mole. So if we use sodium as an example, the way we're going to determine the molar mass of sodium is to look up sodium on the periodic table, and we see that its atomic mass, the number below the chemical symbol in the periodic table, is 22.9898 atomic mass units. And given the magnitudes are identical, we can simply write down its molar mass from this number, 22.99 grams per mole, when we limit our value to 4 significant figures. And it's also worth noting and remembering that the mass of 1 mole of sodium is therefore equal to 22.99 grams. Similarly, for another element, argon, we can look up argon on the periodic table and see that its atomic mass is 39.948 atomic mass units. So we can write its molar mass down directly from this number as 39.95 grams per mole when we round to 4 significant figures. And again, it's worth noting that the mass of 1 mole of argon is therefore 39.95 grams. Now for molecules. The two quantities we compare for molecules are not atomic mass versus molar mass, but rather molecular mass versus molar mass. But again, the molecular mass for a substance and the molar mass for a substance will have the same magnitude but different units. Molecular mass, like atomic mass, has the units of atomic mass units, and molar mass has the units of grams per mole. So if we want to determine the molar mass for the molecular compound water, H2O, we need to look up information about both hydrogen and oxygen in the periodic table. And we know that the water molecule contains 2 hydrogen atoms and 1 oxygen atom. So to calculate the molar mass of water, we need to add up 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen. And we get 18.02 grams per mole as the molar mass. And again, it's worth noting that the mass of 1 mole of water is therefore 18.02 grams. For ionic compounds, we are going to take the same approach, but for ionic compounds, we refer to the formula mass rather than the atomic mass or molecular mass, and we compare that to the molar mass. And again, the formula mass for a particular ionic compound has the same magnitude as the molar mass for that compound, but with different units. Like atomic mass and molecular mass, the units for formula mass are atomic mass units, and the units for molar mass, as we know by now, are grams per mole. So if we look at calculating the molar mass for the ionic compound calcium carbonate, we know it contains calcium, carbon, and oxygen, so we would need to go to the periodic table to get information on those 3 elements. And we also know that the formula unit for calcium carbonate contains 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. And when we sum the molar masses of those 3 atoms, 1 times the molar mass for calcium plus 1 times the molar mass for carbon plus 3 times the molar mass for oxygen, we get 100.09 grams per mole. And again, it's worth noting that the mass of 1 mole of calcium carbonate will therefore be 100.09 grams. So, in summary, to calculate molar masses, we adopt exactly the same principles as when we calculate atomic masses or molecular masses or formula masses, which we addressed in previous videos. And only the units will change. They will change from atomic mass units to grams per mole.